Hello guys, in this video we are going to see how we can use the epsilon delta definition to show that the limit as n tends to infinity of 1 over n to the k is equal to 0 provided k is greater than 0. So this definition says that if the limit of a sequence is L, then for every epsilon that is greater than 0 there exists an n epsilon, which is a natural number, such that whenever n is greater than n epsilon, the absolute value of the sequence minus L should be less than epsilon. Now in this case our L is equal to 0 because it is a limit, so we are going to write the definition in this way. For every epsilon that is greater than 0, we need to find an n epsilon which exists, such that whenever n is greater than n epsilon, the absolute value of the sequence minus 0 is less than epsilon, since 0 is a limit. So doing this, it means we need to begin with u of n minus 0 being less than epsilon, and then we see if we can find an n epsilon which is a natural number. So u of n minus 0 less than epsilon, it means 1 over n to the k minus 0 is less than epsilon, the absolute value, because u of n is just 1 over n to the k. Now from there we can subtract 0 from this, you just get the very quantity. Now we raise both sides to the power 1 over k, and then later we 1 over n to the k raised to the power 1 over k is just 1 over n. We multiply both sides by n, then we divide both sides by epsilon raised to the power 1 over k, and then we rewrite the inequality as n greater than 1 over the k root of epsilon. But if we compare n greater than 1 over the k root of epsilon with n greater than n epsilon, they are similar. So it means we can take our n epsilon to be the greatest integer function of 1 over the k root of epsilon. We are taking the greatest integer function because n epsilon is supposed to be a natural number, and it is not in all cases when 1 over the k root of epsilon is a natural number, so we need to take the greatest integer function, so it solves our problem. Thank you for watching, and see you in the next video.